scratch this, smooth this down on my grinding wheel when it broke. My sandstone, chert, slate. Slate is platey. It came like this, but it broke apart when I was sanding it down on my motor. So we'll see how it reacts under stress. Here's some quartz. I'm curious to see how quartz behaves under stress, what kind of cracks develop. And here's sodium metal. Sodium metal is a metal, pure sodium, an alkali metal. Let's see how it reacts under stress and strain. Well, let's get to it. We got my vise. My other vise in the auto body shop is larger, but it's not bolted down to a table. Let's take the sodium metal. Let's see how it reacts to stress and strain. I'm going to take the sodium metal, place it in the vise, it's a metal, pure metal. Okay. It's now at the point where it's just touching and being held in place. There's no strain or stress applied to it. Let's apply some stress and see what happens. And bring the light in. Now we're going to apply some stress and see how this starts to react in terms of forming cracks, deformation. What's interesting is that there are no, I see some cracks, but it's actually deforming because it's a metal, and metals are malleable and ductile. Now you know what would happen if I threw this in a bucket of water. Sodium metal reacts with water to form sodium hydroxide with the release of hydrogen gas, which in an exothermic reaction ignites and becomes explosive. So I store my sodium metal under mineral oil. I could have potassium, but I'm just not interested. It's an alkali metal. It's on the first family on the periodic table. I'm a prospector of minerals and crystals, but many metals that I have are minerals: lead, copper, aluminum, zircon, nickel, magnesium, sodium, and they come from a ASTM polished fabricator. If you're interested in any copper, I can provide you with copper. Just let me know. I can provide you with any minerals and crystals that you're interested in. Just let me know at Frank Reiser Rocks Minerals at gmail.com. That's Frank Reiser Rocks Minerals at gmail.com. Reiser is Reiser. Let's try the calcite. See how that reacts. Let me look it up. Alright, we have the calcite in the vise. Applying pressure, and already it broke. It fractured right through. It just fractured and broke. Calcite is known to cleave along cleavage planes. It doesn't have a fracture. It is usually not found in massive form unless by erosion, but is subhedral to euhedral. Let's continue applying stress and strain out this calcite and see what happens. Tightening up, more pressure, see what fails next. It's soft. It's 3.5 hardness on most scale. I think it broke already. I'm not sure. We'll find out. Yeah, it did. See, it's squishing. It's squishing sideways. It's giving up. This is solid, it's dry, it's not wet. Here we are. It's solid, it's not dry. It's dry, it's not wet, and it failed. It failed along in terms on cleavage planes because it's calcite. Calcite is one of the minerals that doesn't fracture, but it has cleavage planes. Let's try selenite. Selenite has crystals. It's related to gypsum, but when it is in crystal form, it's called selenite. Rotating it in the wrong direction. Alright, we have the selenite. See how the selenite reacts. I'm increasing pressure. Increasing pressure. How is it gonna fail? I think it failed. I'm not sure. Yeah. Part of it fell off. Part of it fell off like an iceberg curling. Let's try some more pressure. So you can go over the formulas with a cup of coffee because you need it because it's boring. Or you can come to the lab and have a good time and try for yourself and experiment.